Okay, this is my set of friction data. So I've put in my degrees from the horizontal, all right, and then once I get past about 30 degrees, I couldn't actually make the block go with only the 70 grams, so I had to add more mass on the hanger. So that's why I have column B here. Okay, I also have a change in height and a time for each child. So I'm going to use Excel to plug in a formula, and I'm going to say that my acceleration equals 2 times my height equals 2 times my change in height. Okay, and that's divided by my time squared. All right, I'm going to hit enter, and there's my acceleration, and I'm going to copy that formula down for all of the data points. And then I'm just going to calculate the net force on the block using mass times acceleration. All right, so that's Newton's second law. So that is my net acceleration to the left. So this just equals the mass of the block, which is 0.0945 kilograms, times whatever I calculated there. All right, and so then I'm going to copy that down. And for force due to friction, I had to rearrange the equation from the pre-lab. All right, so this equals the force due to friction. So here, all right, I want the mass on the hanger times, we're going to use G equals 10, okay, minus, all right, let's do parentheses times the acceleration, all right, times the addition of that same mass plus the mass of the block. Close both parentheses, and there we go. And again, copy that down. So you should have data that looks somewhat like this, okay, for at least a level, a low angle, and a medium angle. So maybe your first 3 data points here. This was using the wood side of the block for mine, okay? So that's all well and good. So let's graph the degrees versus, I want control, not shift, sorry about that. Degrees versus the force due to friction. So I'm going to insert a scatter plot. Well, that's kind of interesting looking. It looks kind of like a downward parabola, but not quite.